Question number 3. This question is about the extraction of metals. Element R is extracted from its oxide by reduction with hydrogen. The equation for the reaction is given below. Now this is the equation. I can see here what has happened is R has been replaced by hydrogen. This is an example of displacement reaction. So in displacement reaction, you need to remind yourself oxidation and reduction will take place. But oxidation is loss of electron, whereas reduction is gain of electrons. Now here it says the sum of the relative formula masses MR of the reactants. This is given to you as 150. Calculate the relative atomic mass of R. They've given us some values here. So all we have to do is we have to equate this to 150. There are 2 hydrogens here. So I can say it will be 3, 1 times 2 because each hydrogen molecule has 2. So I've got 2 here and there are 3 molecules of hydrogen. Plus, I don't know the value of R for its relative atomic mass. I'll keep it as R, but there are 3 oxygens. So I'll do plus 3 times 16 and this should be equal to 150. Once you've done this, you just have to expand it. So it will become 6 plus R plus 16 times 3 is equal to 48 equals 150. You can add 48 and 6. That will change to 54 equals 150. You subtract 54 from both sides and it gives you R as 96. Next part says identify element R. You should use your answer to question 3.1 and the periodic table. On part 3.1, we figured out that the relative atomic mass is 96. It says you have to use that answer and the periodic table. So if you go on the periodic table and look at the key, it tells you the relative atomic mass is always the top number. So which one is equal to 96? If you look at it, it is molybdenum. So you can write down capital M and lowercase o. Next part says carbon is used to extract tin from tin oxide. The equation for the reaction is shown. Again, you can see here carbon has replaced SN from its oxide. So this is again example of displacement reaction. And just like on the last question, I reminded you oxidation and reduction will take place. It says calculate the percentage atom economy. So you have to recall what do we mean by word percentage atom economy. This means mass of desired product divided by, let's say, total mass of reactants, or you can use products. I prefer the products because then I have to work out 1 less MR. So in this case, I can work out, it says extracting tin. So the desired product is tin. In this case, there's 1 atom of tin and the mass will be 119. Divided by, I have to add the total products, which is 119 plus carbon is only 1 atom. So that will be 12 plus 2 times 16. If times by 100, because we are looking at the percentage, we can do times by 100. If you plug this in your calculator and solve, you'll end up with an answer being 73%. Next part says tungsten W is a metal. Tungsten is extracted from tungsten oxide WO3. All other solid products from the extraction method must be separated from the tungsten. So it says products. So once the product has been produced, and if there are any solid products in addition to tungsten, then they have to be removed. Since table 2 shows information about 3 possible methods to extract tungsten from tungsten oxide. So they've given us 3 methods in the table. We can see here, in this case, this is low cost, this is high cost, this is low cost again. In this case, I can see here there are 3 products. Out of these 3 products, I can say 1 is gas and 2 are solid. So these solids will need to be separated. In the next case, we've got two products again. In the next case, we've got two products, and out of these two products, one is gas and one is solid. So no separation of the products needs to be carried out. In this case, again, I have two products and both solids. The question says, evaluate 3 possible methods for extracting tungsten from tungsten oxides. When they say evaluate, you just have to describe the data given. That's it. So I can say in this case, method 1 and method 3, they are both low cost methods. So the first, I'm going to say method 1 and 3 are low cost. Number 2. Now, if you're using method 1 and 3, then you will have to separate the solid products. So you'll have to say tungsten needs to be separated from solid products. Now, if this is the case, then I can say it will become time consuming. So will be more time consuming. Now we can look at method 2. So I can say method 2 is expensive. In the first place, it is expensive, but no separation of products is required. And in contrast to the third statement, I can also say it will be a quick process.